Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by confirming prerequisites and taking the first concrete actions. Install your IDE and add runtime permissions for camera and storage. This lets the device access frames. Next, pick a reliable decoder library such as ZZing or MLKit so you don't reinvent decoding. Once chosen, add the library dependency and initialize it at app launch. Make sure to enable hardware acceleration or appropriate capture settings to reduce latency and dropped frames. You now implement the core pipeline: capture, preprocess, decode. Open a continuous camera stream with autofocus and a sensible resolution to balance speed and accuracy. Then convert each frame into the decoder's expected pixel format, commonly YUV or grayscale, because color data is unnecessary and slows processing. Once converted, pass frames to the decoder on a worker thread. This prevents UI jank. If frames come too fast, throttle or drop some to maintain throughput and consistent detection. You complete the scanner by polishing UX and handling failures. Draw a visible scan box and add a torch control and audible or haptic success feedback so users know when scanning worked. Implement rotation, correction, and multiple code handling to improve real-world reliability and validate the decoded payload before proceeding. Finally, test across devices and handle camera errors with retries and backoff. If scanning fails repeatedly, check permissions, lighting, and the frame format. Restarting the camera often fixes lockups.
Thanks for watching. Subscribe to keep your life in tune.